Let's look at a little example of when the value of something goes down or depreciates. The value of a new car decreases by about 15% in the first year. In fact, oftentimes I've heard that as soon as you drive it off the lot, it's decreased by 10%. So how much will a car be worth 1 year if its initial value was $1,000, $5,000, $5,020, or X dollars? All right, so because the value is decreasing, then we expect the value to be less than its original 100%. So if originally it was 100% value and we're going to take away the 15% that it depreciates, that's going to leave 85% of its value after 1 year. So if I change that 85% to a decimal, move 2 places to the left, in each of these cases, I'm multiplying 85 hundredths times the original value using our percent equation. So 85 hundredths times 1,000. I know if I multiply something times 1,000, I'm simply going to move the decimal place 1, 2, 3 places to the right, annex a 0. So that car is worth $850 after the first year. The second car, 85 hundredths times 5,000. Well, let's see. I could just take my calculator and multiply these, but I think I can do this mentally. If it reasons that 85 hundredths of 1,000 was 850, that means I decreased by 150. So this is a decrease by 150. Well, since 5,000 is 5 times bigger than 1,000, then I need a number that's 5 times bigger than 150 to represent that amount of depreciation. 5 times 150 is actually 750. So if I take away 750 from 5,000, that's going to leave me 4,250. Again, just looking for some mental math ways to do these problems. And then the third car, depreciation of 85 hundredths, times 5,020. Now this one's not going to be as obvious, probably not as easy to do mentally, so I would probably use my calculator. 0.85 times 5,020 is going to give me $4,267. Now, for each of these instances, we're multiplying 8,500 times the value of the car originally, which in this case, if it were X, this would simply yield 85 hundredths X, where X is the original value of the car.